First, you should know that the converging lens is in your eye also. And what it does is it sees objects rays coming, and it converges the rays onto your retina. But this is inside your eye. There's a special property of this lens. This lens can change its focal length. That means it can focus rays from any object to your retina. So what happens is, if you take a normal glass lens, it can't change the focal length. So these distances, this is the focus distance, this focus distance, these are fixed. These are fixed. So if your object is very far, then you focus on the focus. The lens focuses all the rays on the focus. This is what children do when they play with the rays coming from the sun, and they focus all the rays, they are coming from the sun, by a magnifying glass, which is a converging lens, onto a piece of wood, and that starts burning because all the rays are concentrated here. It becomes hot. This is that. Then the other observation you see is that as you come closer, as the object comes closer, the image becomes inverted, and uh, you can get it on a screen. Now this is this thing happening in the book. Somebody is taking a, a image of a building which is quite close by, and he's got a screen here. So there's a building here, there's the rays come through it, and he puts, and it's inverted. You can do the opposite. You can place your, instead of the screen, you can put yourself, put your eye here, and you will see something like this, an inverted building and a smaller size, because the building is away from the focal length. It's in this situation. The focus is here, the building is slightly far. But if you bring the object very close to the lens, that means this, then the image, though it remains inverted, it becomes bigger. And this is this situation. When he's got an F here written very close to the lens, you see a inverted image of the F on the screen. So this is, you have brought the object close to the, from the building which was quite far from the lens, the object is very close to the lens. So the image is inverted and magnified. This is this ray diagram happening, the ray diagram. So this is that inverted F here. And if you bring it too close, then it gets uh, virtual, it becomes erect. This happens in the uh, in a uh, in a magnifying glass. If you have noticed, you have to put the magnifying glass near the text of the book, and you see a bigger image, and it's erect also. So this is when you start using a magnifying glass, and uh, see it like this. You see this, and the size of the squares has suddenly increased because you put the magnifying glass, the object, the paper on which these squares are made, very close to it. It becomes vertical, and it becomes vertical. This is the diagram. As a convex lens is very, when you come very close, it becomes erect. Generally it is inverted. You see, it's inverted here. The image is inverted, image is inverted. This is the object. This is the object. The image is inverted. But here, when you come very close to the object, comes very close to the lens, the image becomes erect. It becomes virtual instead of being in. This is how you use a magnifying glass on the book. And this is that position. When you come very close, this position. This thing. So the same magnifying glass is giving you different position of the image and the size depending on where you place the object with reference to the lens. You get this table, and you get a table in which you can actually see what happens, that when the object is at infinity, the image is at focus, is very small, is really inverted. When the object comes slightly closer, the image is formed between the focus and double of the focus, it's diminished. And when it comes at the focus, at double the focus, the image is formed at double the focus, the same size, but it's really inverted. As you keep on coming closer, it forms slightly and it's enlarged. This is that F image, and this at infinity was the sun image. And you use these images according to various applications where you place the object in lenses, in microscopes. So you get different kind of images, different size of images. The only exception is your eye, human eye. The human eye is very unique. Its lens can change focus. So here the distance is fixed, the retina is fixed, this distance is fixed because you can't change the eye. You keep on focusing at objects which are different distance. So the only way possible for you to put it at the same image distance on the retina is you change the focal length of the eye. The focal length of the eye thickens when you see something. So that's the strain when you look at objects very close by. It thickens, the lens becomes thick, the eye gets under strain. And if you are so it changes the focal length so that it can focus onto the retina. Otherwise, it would have focused beyond the retina. If this was fixed, then the image would keep on shifting. It won't focus on the retina and you won't be able to see. It will be a blurred image. So the only way this human eye has called a, is called the accommodation. You keep on it keeps on changing the focal length so as to focus the object distance. Image distance always is fixed. The image is always formed at the retina for a different object. Otherwise, if this was fixed, the focal length of this was fixed, then the image would not form all the time at the retina, it would form beyond, and then you won't be able to see, it will be all blurry. I hope you understood.